Okay, this is section 1.9 of Algebra. A solution of an equation with two variables, x and y, is an ordered pair, x comma y, that makes the equation true. So we looked at solutions where there's just one letter in it, one variable, and we plug in a number. Now we're going to be plugging in two numbers, like an ordered pair on a graph. So we're given the equation y equals 4x, and we will plug in the following points. So 5, 20, so I'm going to plug in 5 for x and 20 for y. Remember, our ordered pair is x comma y. So 20 is equal to 4 times 5. 20 is equal to 20. That is true, so this is a solution. B, negative 20 equals 4 times negative 5. That's negative 20 equals negative 20, so B is also a solution. Let's do C down over here. Negative 5 equals 4 times negative 20. So negative 5 equals negative 80. That is not true, so that is not a solution. And finally, D, 6 equals 4 times 1.5. 6 equals 6, so that is a solution. Alrighty, both Carrie and her sister Kim were born on October 25, but Kim was born 2 years before Carrie. How can you represent the relationship between Carrie's age and Kim's age in different ways? So we can put it into a table. If Carrie was 1, then Kim was 2 years older than her, and Kim was 3. If Carrie was 2, then Kim was 4, and so on. And we can fill in a table. We can also write an equation for that. So if we give x as Carrie's age and y as Kim's age, we get the equation y, so Kim's age is equal to x, which is Carrie's age, plus 2. So we take Carrie's age, we add 2, and we get Kim's age. We can also graph it. Remember, when we're graphing an equation, we start with the y-intercept, this 2. We start on our graph at 2. So right here, right there. And then our slope is 1. You don't see it, but that's the invisible 1 that's in front of our x, which is the same thing as 1 over 1. So I go up 1, over 1, up 1, over 1, up 1, over 1, and so on. Okay, let's try our own now. Will runs 6 laps before Megan joins him at the track. Then they run together at the same pace. So first Will runs 6th, and then when Will is running his 7th, Megan is running her first. So I can put this into a table. So when Megan runs 1, Will is running 7. When Megan has run 2, Will has run 8. All I'm doing is I add 6 to the number of laps that Megan has run. 5 plus 6 gives me 11. Can also represent this as an equation. So I'll call Will y and Megan x. Number of laps Will has run is equal to the number of laps Megan has run plus 6. And then I can put that into a graph. 1, 2, 3, 4, 5, 6, 7. I'd start at 6, and my slope is 1, so it's 1 over 1. It's a bad graph, but I go up 1. Here, I'll put this in a different color. Start at 6, I go up 1 over 1, up 1 over 1, and so on. And there's my line. Inductive reasoning is the process of reaching a conclusion based on an observed pattern. We're going to skip over their problem. You can look through it if you want, but we're doing the same sort of thing with this guy right here. So looking at the same pattern, we're going to focus on the orange tiles. So make a table showing the number of orange tiles and the total number of tiles in each figure. So here's our first one. There are 4 orange tiles, and in total there are 9. In our second figure, there are 8 orange tiles, and 18 tiles in total. In our last one, there are 12 orange tiles and 27 tiles total. If we look here, we're adding 9 each time on the bottom for the total number, and we add 4 orange tiles each time. So they want to know how many tiles in all will be in a figure with 24 orange tiles. So I need to keep going. If I add 4, I get 16, and if I add 9, I get 36. If I add 4 more on top, I get 20, and on the bottom I add 9, and I get 45, and on the top I add 4 more, so I get 24, and on the bottom I add 9, and I get 54. So there'll be 54 total tiles when there are 24 orange tiles. Our lesson check. Number 1, we can just plug in that point. So y equals x minus 2. I'm going to plug in 2 for x and 4 for y. So 4 is equal to 2 minus 2. 4 is equal to 0. That is not true, so not a solution. And there's your homework.